Hi everyone, welcome to Socorro's webinar series, Coastal Observing in Your Community. My name is Abby Wakely, Socorro's Director of Communications, and I will be facilitating and moderating the webinar. Socorro is hosting this webinar series to discuss, highlight, and raise awareness about coastal ocean observing activities in the Southeast US and beyond. Socorro is the regional coastal ocean observing system for North Carolina, South Carolina, Georgia, and Florida. We are one of 11 that make up the NOAA-led U.S. Integrated Ocean Observing System, also known as USIUS. Our mission is to sustain and promote observations that help keep you safe. This is a quick snapshot of the technology we support to accomplish our mission. I did want to quickly highlight Socorro has a funding opportunity open. We're looking to fill at least 2 gaps in buoy operations on the east coast of Florida. Proposals are due November 11th at 5 p.m. and you can find the information on our website. All right, let's get to the reason you are all here, the webinar. During the webinar, we highly encourage you to ask questions for the presenter or technical questions for me by clicking the tablet lookout icon and typing your question. I will pose them to the presenter after his presentation. We're recording this webinar today and we'll be posting the recording on the Socorro website. We are very excited to welcome Dr. Chuanaman Hu, who is a professor of oceanography at the College of Marine Science at University of South Florida. He will be presenting today Sargassum Watch from Space. Dr. Hu obtained a Bachelor's of Science degree from the University of Science and Technology of China and a PhD degree from the University of Miami. He specializes in using laboratory, field, and remote sensing techniques to study algal blooms, oil spills, coastal and inland water quality, and global changes. He directs the University of South Florida Optical Oceanography Lab to establish a virtual buoy system to monitor coastal and estuarine water quality, an integrated red tide information system to provide near real-time information on harmful algal blooms, and a Sargassum Watch System to combine remote sensing and numerical modeling to track macroalgae, which we're going to learn about today. So Dr. Hu, that is the end of my spiel, so we can go ahead and get started. And I'm going to turn myself off camera and you can take it away.
Thank you very much. Can you put on my, yes, thank you. Well, first I want to apologize. For some reason, I cannot share my screen. So I asked Abby to share the screen. So I want to first thank Socorro and Abby for this opportunity to share what we do with the audience. As you perhaps all know, Sargassum in the past few years has become a hot topic for a number of reasons. My group has been working with many colleagues to develop a Sargassum Watch System based on space-borne sensors. We study Sargassum using different techniques, and this is one of the things we do. Most of the work presented today has been funded by NASA, but it has also been funded by NOAA, Socorro, and GICUS. This is a teamwork involving many peoples, and this is the incomplete list on the screen. I thank them for their contribution. Next slide, please. So here's a very simple outline. I have only 4 things to talk about today. First, I want to give an introduction on the phenomenon. Then I'll lead you through exactly how we watch Sargassum from space. Then I'm going to show you several applications. Then I'll end the talk by talking about what's next, what we are going to do in next steps. Next slide, please. Very quickly, perhaps you all know this, but let's review. Sargassum in the Atlantic is mainly from 2 species, Sargassum fluitans, Sargassum natans. They have different morphology. One is the thicker, the other is the thin. The one clump of Sargassum is about 10 to 20 centimeter in size, like our palm. So these are the main morphology and species in the Atlantic. Next slide, please. Most of the time, Sargassum in the open ocean is a critical habitat for many marine animals. Because of this, the Sargasso Sea Alliance called Sargassum mats as a golden floating rainforest of the Atlantic Ocean. So it's very important. If you want to collect the sargassum in US waters, you need a permit from NOAA to collect sargassum, just for this reason. Next slide, please. But as with many other things, too much of a good thing can make it very bad. If you have a lot of sargassum on the beach in your coastal water, it may become a nuisance. It may smell very bad, attract insects, clog water intakes, and it may smother turtle nesting sites. It may cause some health problem of humans. So there are a lot of problems, and that's why sargassum blooms have caught so much attention in the past few years, because most people living by the coast see sargassum as a nuisance, even though in the open ocean is a critical habitat. Next slide, please. So in Florida, we are not immune. So these are just two photos to show what happened along Florida beaches, coastal waters, along the east coast of Florida and in Florida Keys. And now they tend to occur every summer. And sometimes they start early by spring. Next slide, please. But if you think this is severe enough, that's wrong. If you look at the Caribbean, next slide, please. Actually, this is what most sargassum blooms, what most sargassum beaching have occurred. So the previous slide show an animation in the Caribbean Sea. You see the intense bloom is unprecedented. And so currently, well, in the current screen, you see the sargassum bloom in the Gulf of Mexico. It's less dense than in the Caribbean, but every summer we still have this sargassum in the Gulf of Mexico. Next slide, please. So sargassum has been found in almost everywhere in the Gulf of Mexico, Caribbean Sea, the Atlantic Ocean. Now the question is, how do we monitor and track sargassum? Well, there are many ways. The most effective way for large-scale tracking monitoring is through satellites, because these satellites can provide daily synoptic view of the entire Atlantic Ocean. Okay? But as to exactly how, there are several techniques. There are several technical steps we have to go through, just like when we want to detect anything on the ocean surface. This is not just restricted to sargassum. So anything, including marine debris. So there are basically three conceptual steps. One is there something in the image? Okay. Do you see anything abnormal? That's step number one. Number two is, what is that something? For that, we need to use some spectral information to discriminate this spatial anomaly. The last one is, how much is that something? So we have to apply pixel mixing to estimate the quantity of whatever is on the surface. So these are the three technical steps, but in practice, there are many more things going on into each step. Next slide, please. Next slide. Okay, good. So in practice, we have to first go to the field and measure sargassum or other macroalgae, previous one. So there's a delay in between the keystrokes.
Sorry about that.
It's
and
okay.
All the technical difficulties.
Yeah. So we have to measure this, measure the amount, measure the reflectance corresponding to different amount. So we call this amount a biomass density. So that's the weight per unit area. So we measure both the spectral reflectance and the biomass density. And from this, we can establish a model, okay, to relate the reflectance to biomass density. Because reflectance can be derived from satellite measurements. Okay? At least conceptually, we can derive sargassum biomass density this way. And of course, in practice, we have to go through a lot of steps to establish the model to relate the reflectance throw an index with the biomass density. The index is either alternative floating algae index or floating algae index. So on the right-hand side, you see how the index from the reflectance is related to biomass density. So this is the model we use. But when we apply to satellites, we have to deal with the clouds, sun glint, stray light, and atmosphere perturbation through aerosol or other atmosphere constituents. So it's more complicated than just a simple model. Next slide, please. So this is the sequence to show how we apply that field-based model to satellite images. The first image shows a floating algae index anomaly. So you see something in bright color there. Then we apply an image processing technique to extract the anomaly. So the red pixels, we know there's something going on there. Okay? Then we look at the spectral shape of the red pixel. And then it's a sargassum. We know it's a sargassum. Okay. That's the next image. Image is number 3. We know that's sargassum. Then we apply this field-based model to estimate how much sargassum is there in terms of biomass density. That's black and white. It's a color scaled as biomass density. So that's from one image. But you see there's a lot of gap that due to cloud sun glint. So how do we remove the gap? Well, we put many images together. Each image is like image D. So we know everywhere the biomass density. So we just put many images together to calculate an average and to result in the bottom right image. So in every location, we have the biomass density. Next slide, please. So to make a complicated process simpler, here's the illustration of this whole conceptual steps. This is what you see from a satellite measurement. It's a 2-color composite. You see cloud, you see sun glint, but other than that, you don't see much from the space, from the image itself. But after we apply our technique, next slide, please. This is what you see. After we apply the floating algae index technique to the RGB image, you see some color anomaly. There are some features. So what are those features? If we look at the spectral shape of those features, that is shown in the graph, inside graph. So these shapes resemble those of sargassum measured from the field. So they have a red edge reflectance above 700 nanometer. They also have a brownish peak around 620 nanometer. That's a brownish. So what is a brownish vegetation on the ocean surface in this part of the ocean? That's the Caribbean. It's a sargassum. There's no other explanation. Okay. So, but you see, there's still a lot of clouds. So next slide will show. Next slide, please. Once we put a lot of images together, all those clouds of sun glint are gone. So we have a cloud-free image. That's a 1-week composite image to show the biomass density. So this is how we map sargassum from space, step by step. But we did more than this. Next slide, please. So we put the image in Google Earth and combine with the surface current. So every user, by clicking on the image icon, can bring the image and the surface currents into the user's Google Earth interface. So that way the user can navigate, can zoom in, can estimate the current direction and speed. So that alone is a short-term forecast tool. So you know where is something, then you know how fast and the direction of that something is moving to. So you can predict in the next day or two where you can encounter a lot of sargassum. So with this, we expand the concept to a lot of regions. Next slide, please. To cover the entire Gulf of Mexico, entire Caribbean Sea, and also the west coast of Africa. So we have a lot of subregions, and every subregion is covered by MODIS, by VIRS, by the Sentinel-3 sensors. We have a web interface, and every day, the weekly composite is updated. You can click on the GE image icon and to bring the image and the surface current in your Google Earth system. So next slide. And the website also has an animation tool, so you can define your period of interest and start an animation to show how Sargassum moves in the past month, past 2 months, or past year. I'm sorry, the bandpass is not wide enough to show smooth transition, but if you download the recorded presentation, you may see a smooth movement of how Sargassum is transported from the Caribbean to the Gulf of Mexico, and then it makes a turn to flow through the Strait of Florida to go to east coast of Florida. Okay? So this is the Secura domain. So some of the Secura domain is impacted by Sargassum with the Caribbean origin. Okay? Next slide, please. So from now, we have this Sargassum Watch System based on satellites established, and it's presented on the web. It's a web-based tool. Other people can make use of this tool. And here I want to show you some applications using that tool. One of this is used by the NOAA AOML Coast Watch. So they pull out these products and insert the products into their system as the additional layer and combine with their ocean currents and other variables to predict the risk factor of each coastline segment. The prediction is based on statistics. So what is the proximity of the large Sargasso mass to the coastline? How much is the wind? And what is the current strength, current speed, or current direction? It's based on statistics. So with this, they can highlight different coastline segments as a high risk, medium risk, or low risk. They produce this every day. So one of the input layers is our Sargassum Watch products. Next slide, please. Okay. And of course, you can focus on the small region to see what happened in the past 10, 12 years. So if we focus on this EEZ of the Mexico, the Caribbean side of EEZ, we can extract a time series to see how Sargassum impacted the EEZ of Mexico on this side. So the top graph shows the later years would have actually had more Sargassum than before 2015. And it fluctuates, but we definitely see a trend. And likewise, on the bottom graph, we show how Sargassum amount changed over the past 10, 11 years in the Straits of Florida. It's similar. So the later 5 years, from 2017 to 2022, had way more Sargassum than before. Okay. So we can focus on each individual region to have a time series graph. Next slide, please. And we can also combine other data products to understand how Sargassum is transported from one place to another. On this slide, we have several examples to show how Sargassum is transported from the Caribbean, the Northwest Caribbean, to the Gulf of Mexico by the loop current and by the loop current eddies. So if we have animation, the animation would clearly see how the Sargassum patch follow the current, follow the eddy to move from the Caribbean to the northwest of the Gulf of Mexico. And some of them is transported to the Strait of Florida to reach the east coast of Florida. So we try to understand how that's transported. That's called tracking. So it's the beyond monitoring, it's a sargassum tracking. Next slide, please. Then if we scale up to see the large picture, we can see how sargassum is distributed in the entire Atlantic Ocean. So this is what we call the Sargassum, Great Atlantic Sargassum Belt. It extends from the West Africa to the Gulf of Mexico during almost every summer in the past few years, with a huge amount of area. Okay, so the paper was published in 2019, with the time series stopped in 2018, of course. I think, well, by that time, it already made a Guinness World Record of the it's the largest macroalgae bloom. But now the record has been broken by this year. Next slide, please. So the real record is in June 2022 this year, not in June 2018. Okay, so it's 20% more sargassum. And in the entire Atlantic, we do see an increasing trend. So if you ask me, where are we going? Is this a new normal? I would say yes. 3 years ago, we said yes, and now I still say yes. And perhaps it will fluctuate. In some years, it may even be bigger than this year. Next slide, please. So based on source, every month, by end of the month, we summarize what we see from the current month, and we predict what would likely happen in the next 2 months. So we send out this monthly one-page bulletin to subscribers, to interested users. So every month we show where is the sargassum, how does it look like, and how does it compare with the same months of previous years. And what about the next 2 months? So we give a short-term forecast. But this type of forecast has nothing to do with how much sargassum would land on your beach. This is a general outlook, a large picture. For beach-specific forecast, we'll need other tools, or you need to develop other tools. Okay, next slide, please. Yeah, so this type of tool has been, this source, along with the monthly bulletin, have been used widely by many stakeholders, by many user groups for different purposes. So one of those usage is to determine where you want to release young turtles. So these young turtles are strangled on the beach after storm. They are rescued, but we want to know where to release them so their survival rate is high. Sargassum is a habitat for turtles, so people want to find a sargassum to release the turtle. So the source would help people to find sargassum to release the turtles. So that's one use. Others, the boaters, want to know where the large amount of sargassum is to either avoid them or determine where to go fishing. Next slide, please. So this is the famous magazine for the Caribbean boaters. So they frequently quote what we see from source. Next slide, please. And next. So sometimes they just quote the entire bulletin to showcase what is the likelihood of sargassum amount, the large sargassum amount in the next couple of months. Okay. Next slide, please. So all I have been showing is a large-scale Sargassum Watch System that is useful to provide large pictures, the general outlook. But many people would ask, what's happening on my beach? That's a very relevant and critical question. Because most people really care about what's happening on the beach and in coastal water, can they swim, right? So are these large-scale general products accurate enough to predict what would happen on the beach? So this is one study from a group of University of Miami. So on the graph, it shows the Sargassum amount on the beach. I can't tell which is which. Okay, so the empty symbol is the Sargassum amount. Okay, is the volume of Sargassum the local management agency has removed from the beach. Okay. What beach? To the left, you see those beaches. It's all together. Okay. So that's the total amount of Sargassum, the empty symbol. The solid square, that's the Sargassum amount. Of the Caribbean Sea and the Central Atlantic, that's a huge area far away from these beaches, remote. But you see, in general, their patterns are pretty close. Okay? They are synchronized. Okay? So that is a good prediction of general outlook on the beach. But we are not always this lucky. Next slide, please. So on the Cancun beach, okay, of the Yucatan Channel, so there are a lot of hotels, you can imagine. So they work together to remove Sargassum every month. So on the top, that shows the total Sargassum removed by 7 hotels along these beaches, 1 through 7, the total amount between 2018 and 2019. So you see a seasonality. Okay? Then on the bottom, that's the Sargassum amount in the Mexican EEZ, just beside those 7 hotels. So although the seasonality is the same, every summer, late spring, there's a peak, okay? But the pattern is opposite. So in the hotel data, 2019 had the largest Sargassum amount removal, but in the EEZ Sargassum, 2018 had the largest amount. Right? So that's the opposite. So that means even though the general outlook is okay for a large picture, as for individual beach, you really need to look closer to have a zoom-in picture to develop a local system. So how can we do this? Next slide, please. There are a lot of high-resolution satellites. So these days, remote sensing has really advanced as compared to 20 years ago. There are many, many high-resolution satellites. Some of them are commercial, others are public use. So on the left, that's a Sentinel-2 MSI image to show the coverage, the footprint. It covers almost the entire Les Antilles Islands in the Eastern Caribbean Sea. If we zoom in into a very small region, you see there's a Sargassum patch. They are greenish because we use a near-infrared band for the green channel of the RGB. But you see those Sargassum mats. They are about 10 meter to 300 meter in length. So these are small beaches if, these are small Sargassum mats if we use coarse resolution data. But they're showing up so clearly. And then we have a 3-meter resolution Dove images. We have a 30-meter resolution Landsat images. So they can all show the small-scale Sargassum features. It's just a matter of algorithm development to extract these features, to estimate the amount, to exclude the confusion factors, artifacts. Okay. Next slide, please. There are different ways to do this. One way is through machine learning. You may have other ways. Okay? So there are several papers out there. So one way we used was through deep learning. So there are different ways of machine learning. So the deep learning has the advantage of using not only the spectral information from every location, but also using the spatial context or texture to recognize that is not noise, but that must be Sargassum. So we train the machine learning algorithm with a lot of Sargassum features. So this is the result on 2 beaches. One is on Miami Beach, the top row. The second is on Cancun Beach, the bottom row. So the beach is about 10 kilometers long on Miami Beach. If we zoom in a small red square, we can see on the RGB composite, the top, I have 4 small segments. small icons, 100 meters each. You see this dark patches. Okay. If you look at the spectra, you know these dark patches are not due to color dissolved organic matter because they have red edge reflectance. So these are due to decaying sargassum. Okay. Then we can build a deep learning algorithm to extract these dark features. So that's the second row. The dark brown is the sargassum on the beach. The light brown is the sargassum on water. Then we can quantify how much sargassum is on the beach and is on water. Likewise, we do the same thing for the Cancun beach. We can quantify. Now, if you look at the image date, look at how frequent we can do this after discounting cloud cover. These are cloud-free days. On top row, we have May 28th, and 4 days later, June the 1st, 2 days later, June 3rd, 2 days later, June 5th. Then for the Cancun beach, it's almost every day. So this high resolution data, 3-meter resolution, cover the beach every day. Okay? And some days we have clouds we just don't use, but they provide a near real-time system if you have data access. These are commercial data, okay, from Planet Scope. They sell the data, but we are funded by NASA to have access to this data so we can demonstrate the potential of this data. Okay. Next slide, please. Then if we do this over the course of 2 years or 2 months in this case, we can see how much sargassum is on the beach every day, how much sargassum is on the coastal water every day. And so the red or the brown color is sargassum on the beach, the amount of sargassum on the beach. For Miami Beach to the left, for Cancun Beach to the right. And you clearly see a seasonal fluctuation within 3 months. So there are 2 peaks, just like a tide, one wave after another on Miami Beach. But the Cancun Beach is almost constant. There's no such 2-wave tide. Now, if we have the capacity, or somebody has the capacity to do this automatically, then we have a beach specific monitoring system. Okay. But so far, we are not able to do this because writing a paper is one thing, establishing an automatic system is another. Okay. But the capacity is there, the potential is there. Next slide, please. So recently, actually, this is just the past summer in July. So there are 2 water intakes of a local desalination plant of the US Virgin Islands. So they are both clogged by sargassum inundation. Imagine if we can establish a high resolution, a local monitoring system, we can certainly provide early warning to the local people. So there's a large amount of sargassum coming, so you need to prepare, make sure it's not clogged. And because of this clogging, the local agency declared a state of emergency. Not because of sargassum on the beach, but because of the sargassum clogging on the desalination plant. So there's a crisis of fresh water use. So there's still a lot of work to do. But we know the capacity is there. Yes, thank you. Next, that's a summary. It's my last slide. So in the past, I would say 10 years, we have to work hard to establish a Sargassum Watch System. This is because Sargassum bloom started to appear in 2011 in the Caribbean Sea. So in the past 10 years, we have been working on this. But the system was not there until 2016. It takes a lot of work, but now it's automatic. So every day, the internet is there. If the satellite data stream is there, no interruption, we can go home. The images just pop up automatically every day. Okay? So this way, we have automatic system to serve the entire community, all users. Everyone can have access to the product. Then every month we distribute Sargassum Outlook bulletins to many subscribers, and they further distribute to their subscribers, to their user groups. So we want to serve the people. Then on the research side, we found recurrent Sargassum belt from the West Africa to the Gulf of Mexico. And this belt has no sign to stop. It will continue in the coming years. Then finally, we have found the multi-sensor high-resolution imagery can provide much better image quality for local regions. That's no wonder. But how to realize this capacity for a local system? That's the next step. My group has been funded by Sakura to establish a prototype system to focus on 1 or 2 beaches to see how that works. And that, I hope, will be established in a year or 2. So we have some automatic system to focus on certain beach. And so far, I have only shown how we monitor, how we track sargassum. I have not even talked about anything about why we have so much sargassum. Now, why do we have more sargassum in some years and much less in other years? And why did sargassum start in 2011? That is a whole beast by itself. And that's going to require more than one seminar to go through. But there are currently a lot of research to focus and also to debate on why in some years we have more sargassum. What is the fundamental reason? Can we really predict the future based on what we understand of why? So that's the next. And I know many groups have been working on this topic. And if you are really interested, I ask you to pay attention to new publications in the next 1 year or 2. With that, I want to stop and thank you very much for your attention. I hope I can address questions if you have. Thank you.
Sorry, I was on mute. If you guys have any questions, please type them into the tablet-looking icon into the Q&A box, and I'll ask Dr. Hu. We've had quite a few come in, and we'll be on until noon, and lots of kudos coming in. This was one of the best presentations we've had. So the first question is, for the data on the sargassum removed by hotels in Quintana Roo, could it be that a higher ratio of what landed on the beach was removed in 2019 than in 2018, and that therefore the data looks different, not because of less sargassum beached in 2018?
Well, that's certainly a possibility. I actually don't know exactly how they remove the sargassum and how they make record the data. It's my collaborator in Mexico who collected all this data from the hotel, but that's certainly a possibility. But in reality, it's really difficult to have consistent data across different hotels and across different local regions. People use different methods, but that's a great point. And for that, I ask you to pay attention to a citizen science project. I think the PI is at the Florida International University. So they rely on many people to collect sargassum relevant data on beaches. And next step, I envision we're going to rely on those data to cross-link with what we see from satellites, to have a validation or to have a better use of a combination of citizen science and satellite remote sensing.
Thank you. The next question has come in. Are fixed camera or drone surveys practical ways to monitor sargassum locally?
Absolutely. I'm glad you mentioned this. You can certainly mount cameras on beaches, on fixed platforms to monitor sargassum every 5 minutes or every an hour, just like how you collect the temperature from a buoy. And that will provide a high resolution, fine detail, continuous data. Then combining that data with satellite observations would give you a much better feeling or much better monitoring and forecasting capacity than using satellite data alone. So even with the high resolution satellite data, remember we have clouds, we cannot see everything every day. But with the camera, with the drones, you do have a better capacity to monitor local region. So it's just a matter of how you do this. You know, do you have enough resource and personnel to support this? You know, that's continuous. It's quite expensive to operate a drone continuously.
Great, thank you so much. Another question that has come in, how did the area of Sargassum change with a change in resolution?
That's another great question. We all know, you know, the Sargassum Watch System is based on 1 kilometer resolution data. So every tiny pixel is 1 kilometer square. And how much Sargassum need to be in that 1 kilometer square in order to show up in the image? So from our estimate, it's 0.2%. Well, 0.2% is not big, but the pixel is very large. So 0.2% is equivalent to 2 meters by 1 kilometer. If the Sargassum size within that 1 kilometer square is smaller than this, we don't see anything from satellite image. So we miss a lot of small Sargassum patches that way. But if you do have a lot of small patches scattered around within that 1 kilometer square, we can still see them. So the caveat is if you don't have enough in that 1 kilometer square. But then it comes to the question, how much Sargassum can we detect from higher resolution satellite images? Well, every sensor has its limitation. So even with the commercial sensor, 3 meter resolution, the limit is about a size of a small table. Lower than that, you can't see those. So we do miss a lot of small Sargassum clumps. But how much do we miss those? It's almost systematic. So we have compared, you know, thousands of image pairs between coarse resolution and higher resolution images to see, is that a systematic or random? We hope it's systematic. So at least the temporal patterns are still correct. It turned out, yes, it's a systematic. So if we look at a large enough area, if my data say it's 100 kilometers square, well, if you have high resolution data, it may be 150, but it's always that way. So that's good news. But we do miss a lot. Thank you.
Thanks for that. Another question has come in. Are you looking at what is happening to the Sargasso Sea in the North Atlantic? Is any Sargasso feeding the Gulf, or is the Sargasso Sea increasing or decreasing? And do you see a connectivity between the two Sargasso Sea and the Great Belt?
There's a large-scale ocean circulation to bring Sargassum from one place to another. For this particular question, Sargasso Sea does receive Sargassum from the belt and from Gulf of Mexico in two different pathways. One is through direct transport from the belt and around the Bahamas Bank, then going directly to the Sargasso Sea. Another path is to go through the Gulf of Mexico, through the Straits of Florida, then to the Sargasso Sea. There are two pathways, but Sargasso Sea does receive Sargassum from those. And vice versa, Sargasso Sea does provide Sargassum to the Sargassum belt through ocean circulation. So it's just like a circle. But I have not seen the Sargasso Sea providing Sargassum to the Gulf of Mexico, reversed. That's because the strong Gulf Stream, it would not allow a reversal of the transport. As to the question, do we see a decline or increase of Sargassum in the Sargasso Sea? Well, I have not plotted any graph, but it looks like we do have some increase in the Sargasso Sea. But once we stop this, we end the seminar, I'm gonna plot some time series in the Sargasso Sea to see what happened. Thank you for asking that question. And If you want to know the answer, you may email me offline, so we can continue.
Great, thanks so much. We had another question come in. Is there any study looking at the use of the SAR sensor on the satellite for monitoring to reduce challenges with cloud?
Okay, that's another good question. I'm happy to tell you we just published a paper to answer exactly that question. Not just on Sargassum, but also on other macroalgae in other parts of the ocean. So how can SAR, the synthetic aperture radar, be used to monitor macroalgae blooms on the ocean surface? Well, the answer is that depends on how large your Sargassum mat is. For large mats, you can see those from SAR images. But for smaller mats, we cannot see. One thing may question, well, that's the same for MODIS, for visible satellite, for small mats. But I'm comparing the optical images against the SAR images. If optical images can detect 1,000 kilometers square, SAR may detect only 100 kilometers square. So it's really limited. But depending on wind and depending on the size of the Sargassum mat. So if you want a simple answer, yes or no, I can say yes in certain cases, no in other cases. And most cases, maybe no.
Great, thank you, Dr. Hu. We've had another question come in. With the changing climate patterns, would the possible slowing of the Atlantic Meridional Overturning Circulation, AMOC, affect the rate or the magnitude of Sargassum transport?
Wow, you beat me. I can't answer that question. Sorry. I don't want to put some answers based on purely on speculation, but that's a great question.
Thank you so much. And maybe we can share your email and you guys can discuss it offline.
Yeah.
All right, so I'm not seeing any more questions in. I am seeing so many kudos, Dr. Hu. This was one of the best presentations we have. It was so easy to understand. So I really thank you taking the time. We'll hang on for one more minute. I am going to try to pull up your email so we can go ahead and share it in the chat with folks. It is opening right now. Just give me 1 second. And as I said, if you guys have any more questions, please type them into the chat.
Thank you, Abby.
You're welcome. All right, so your email is in the chat and just lots of thanks and kudos coming in. Really wonderful presentation. If you guys have any questions that one question. And I think I know the answer. Dr. Hu, can we make your slides available to everyone who attended the webinar?
Sure.
Great, wonderful. So Eric, yes, they will be available. All right, well, I'm gonna go ahead and end the webinar because I don't see any more questions, and everyone who has registered will receive a recording and the copy of the slides. And thank you again so much for spending your lunch hour with us. And thank you, Dr. Hu, for such a great presentation. Really appreciate it.
Thank you, everyone.
All right. Bye, guys. Have a lovely afternoon. Bye-bye.